Thank you very much. Good morning, everyone, and welcome. My presentation for this lightning talk is the Parse is right, using Clojure and ClojureScript to examine the structure of English. Basically, a brief summary of work I've done in the past year to write an app that I've named Macaulay. No, not that Macaulay. This Macaulay. This is a picture of James David Macaulay. He was professor of linguistics at the University of Chicago and one of the leading theorists of syntax of natural language in the 20th century. He passed away in 1999 of a sudden heart attack at the age of 61. He was a teacher of mine, and it's in his memory that I've named the app you're about to see in his memory, Macaulay. You're computer developers, so you use the word syntax in your everyday vocabulary. But syntax, when it comes to linguistics, and particularly when it comes to natural language, has a slightly different meaning. It specifically refers to the study of the rules whereby words or other elements of sentence structure are combined to form grammatical sentences. To elaborate on that a little bit, everyone knows that words can be classified as parts of speech, the canonical noun, verb, adverb, adjective, and so on. Those parts of speech can be assembled into structures, given the rules of the syntax of English. Running a quick example, short example, in fact, the shortest example in the King James Version of the English Bible. Book of John, chapter 11, verse 35. 2 words, Jesus wept. Everyone knows Jesus is a noun, wept is a verb. Well, English has a rule that says that a noun and a verb can combine to form a sentence. In fact, that is the rule right up there. Noun plus verb equals sentence. And that's just one of a host of different rules that the syntax of English has to basically take words and their parts of speech to be fit together to create tree-like structures. And that's what Macaulay does. But to talk a little bit about the tech behind this in this tech talk, we have an API backend with a web endpoint that's written in Clojure, specifically invoking ring and composure, and also particularly using the natural language parser that was written at Stanford University from the core natural language processing group, the NLP group as they're called. And that's written in Java, and it turns out that that also plays nice with Clojure. That takes text as an input, and I've written the app so that the backend API so it delivers a JSON object as output. That JSON object is then passed through an HTML front end involving which written in ClojureScript, taking that as input and delivering back JavaScript as output, and particularly JavaScript written with the D3 graphics library using our good friends Reagent and Figwheel as part of the process. So to run through this very quickly, taking our example, Jesus wept, goes through a web backend that looks something like this, and it delivers back an an S expression that looks like that. Shout out locally. Turns out that things like this, the NNP and VBD, those are pen tags, or pen part of speech tags. A shout out to the University of Pennsylvania Linguistics Department. They created a taxonomy of 36 different parts of speech that this parser uses. So we've got a bit of a local connection that's used in this app. And you can actually see the constituent relations. That's what the parentheses, the limit, so you know what is what as far as the constituent arrangement is concerned. That S expression goes into another Clojure function that delivers a JSON object like you see below. That then goes as input into the ClojureScript D3 library, and the output looks something like this, complete with colors and drawings and parts of speech, and much easier to be able to read and parse. So that's kind of neat. It can draw trees, but who cares? Well, actually, you should care. It turns out you can do a lot more than just analyze trees. There are actually some applications that are at play here. For example, you can actually use the trees that are generated in Macaulay to more intelligently search for words and their immediate surrounding context. One example that I could bring up here, among others, sentiment analysis. Turns out you can actually take words that you're searching for, look within the search parameters of other words that bear positive or negative sentiment, within that tree, be able to compare the two and be able to analyze that more broadly. Another example, it turns out you can actually also use Macaulay or basically the data delivered back by Macaulay, to help to diagnose the risk and likelihood of neurodegenerative diseases. There's been research done here that it turns out that the number of idea-bearing nodes, as they're called, which actually are correlated to parts of speech, and the percentage of that for every 10 words that you speak or read, it turns out has an uncanny correlation to the likelihood of dementia and Alzheimer's disease. More details on all of these are in a presentation I gave last month before the Chicago Clojure meetup. The video is on YouTube. Do a search for the Parse is Right Clojure for a presentation where I go into this in much more depth. If you wanted to look at the code I'm happy to report is online. Back-end API, front-end HTML, front-end HTML, and a bulk processor that takes data for as a text file, delivers it out sentence by sentence, and delivers out trees for each sentence and statistics therein. Enough talk, let's see the app in action. Size it up a bit. There we go. Okay. So looks like this. You'll have a number of buttons. And so if you take a sentence like this and paste it in here, and then parse it out. Animation. You also have a battery of statistics here. One more example, a little longer one. This is a bit irony. It is wrong to say that text is unstructured when there is a great deal of structure in text, and we do ourselves no favor to ignore the lessons it can teach us. And we are at time. That concludes my lightning talk. Thank you very much for your time and attention.
Good morning, everyone. So today I'm going to talk about another library to deal with the Java JDBC. So, so you might ask this question: why do we need another Java JDBC Clojure JDBC library to deal with the database? We already have a lot of libraries, but why? So that's pretty much. So we have been using all those libraries gradually, and then switch from one library to another library. So the library we come up with is pretty much based on our experience, and then there are a few problems we're trying to solve, and end up we come up with a new library. So it's pretty natural, right? So let's take a look at the code. So let's take a look at the code, and then I'll explain why we need another library and why these libraries it might be helpful for you as well. So for us to query database, the only thing we worry about two things. First one is in the query. The second thing is in the parameter for the query, because your query needs to be parameterized. So this library basically needs to provide a macro for you so that you can basically just put it a query string, provide a query string and the parameter. That's the only thing you need. And then after that, you will be able to call this function directly, and then by giving the database connection. So that's a simple query. And also the parameter can be can have the type annotation. It becomes a little bit better because some of us like types. But if you don't like type, you can ignore it. But the type doesn't stop from here, so it gets a little bit better. And also the types support a very complex type as well. Like you can support an array, because in the case where you need to pass a list of ID into a database query as a parameter, and then you can do that. So one nice thing about this one is with this array, you don't need to kind of dynamically generate a query or generate the question mark in your SQL string, so that you basically just bind this variable directly to the SQL statement. So, and then you can just pass in the array as a parameter. And one nice thing about this one is a lot of library right now, they deal with parameters. They parsing most of them, just create a function. That function will take a arbitrary map, but there's no way you can guarantee the map has the exact structure you want. So which cause a lot of problem in our code base. So yeah, so by going through this way, there's no way I can mess up with the parameter because the parameter is ordered and it will be checked at the time when the code gets compiled. So let's keep going, and then it also, so the second part is about the result set. And once you can pass in the parameter, you can run the query, then you need to deal with the result set. So result set, and also you can provide an optional map so that it can the library provide a bunch of functions so that like if you know the result set will be only one record, then you can say single. And if in case that it's not a one record, like it's written more than one record, then you will do exception. And also you can say, okay, I only care about the first record, then you can just say, okay, rows I only care about first. You change the single to first, you get that one. And also if you have a very complex business logic needs to handle the result set before it returns, you can also provide your own function over here. It can basically, it takes a keyword and also a function as well. So that's about this part, and also test. So for database, I don't like to write test for database query. So one good thing about the library is you don't need to write a query test for your query anymore. So you basically just use one line of code, and your whole namespace, anything in your namespace, any query in your namespace will be. You also need to provide database test database connection function, and then you will get to post to the database server, and then it gets run, and then you can verify the correctness of your SQL statement. That means you don't need to write one line of code, all your SQL will get tested. So then let's come back to ask about why we need this library, because first thing is you get a compile time check for the query parameter, and also we're not parsing any SQL statement at all. It's basically you passing SQL statement. There's no way you can make the parse right. And we're not concatenating any SQL, so obviously, and then also testing is so much easier. So if you're still not convinced, that's the one function I got from our code base. As you can see, there are 3 insert query and 1 SQL statement. I don't think any other kind of library, any of them library, they try to parse the SQL, and there's no way they can get this kind of complex syntax. But I bet everyone could understand the query over here, because it basically just a list of parameter and the SQL statement. And your SQL, you can give it to anyone who understands SQL, and they will be able to provide a SQL for you. So yeah, that's about the library, and then here's the GitHub project. Thanks a lot for your time. Yeah.
Good morning. My name is Eric Shull. I am a software developer at Atomic Object in Grand Rapids, Michigan. And besides drawing sketch notes of conference talks, I also make a lot of small in-browser web apps with Clojure script. So an in-browser web app is exactly what it sounds like. It's actually more of a single-page application or client-side application than what usually goes by that name. These don't have any server backends. They don't talk to anything. They don't have any routing or any application or any authentication. And they're really quite simple. They're more UI experiments, board game helpers, GPS data visualizations, compact calendars, manufacturing line simulations, geometry sketchpads. And for a long time I did apps like this in D3, which D3 is a great library, but it is not necessarily very good for managing the state of your entire application. It keeps a lot of state, and it keeps it in the DOM, and it becomes very difficult to manage that and to transition between arbitrary states. And so I started looking for a better alternative paradigm for building the sort of apps that I tend to build. So a good place to look for alternative ideas is the Elm programming language. It's a functional reactive programming language. And about a year and a half ago, it introduced a way of rendering HTML pages. And the library that it used did DOM diffing and patching, but it did not use React.js. Instead, it used a library called Virtual DOM, which is a standalone JavaScript library that implements the DOM diffing and patching that you find in React, but without any of the other stuff that React has. There's no components and the various other things. So the Elm library for doing HTML implemented that, and it introduced what it referred to as the Elm architecture. The Elm architecture is very simple. You have a model, which is a centralized representation of your application state, not unlike Elm Next. It is passed to a pure view function, which produces a virtual DOM tree. That virtual DOM tree is compared to the previous virtual DOM tree in order to generate a list of patches to apply to the actual DOM and then bring it up to speed. And what you can't see down at the bottom, there is an action that can get produced at any time, either by user actions or other processes. And that triggers an update to the model, which then kicks off the whole process again to bring the DOM up to date with the new state. So it's a very simple model. Elm, being a functional reactive language, has signals. And since ClojureScript has core async, it has channels, which means we have something of a stand-in for signals. They're not quite the same, but they'll work in this case. So I thought, what if I implement this Elm architecture in ClojureScript? How do I find that for implementing, simple applications? So here's a render function generator. This is a function which takes an element and then returns a function that takes virtual DOM trees, calculates the diffs, the patches, and applies them. And then it's all within a function closure which keeps track of the state between calls to the function that it returns. Elm uses a function called fold-p, which is in essence a channel-to-channel form of reduce. It takes an update function, an initial model, and an input channel of actions. And anytime a new action comes in, it passes that action and the current state of the model to the update function and produces a new model, which is then put on the output channel. This is an example of the step function. This is an update function. It gets the model and the action. It uses core match to dispatch what to do given a particular action. In this case, the actions are just simple keywords, but they can also be parameterized. And you can do nothing. You can change the model. You can trigger actions that have nothing to do with the model and are just side effects. And then your application setup down here at the bottom is just create a channel for your actions, an initial model, create a channel of models using fold-p, and then you can use core async's map function to turn that channel of models into a channel of virtual DOM trees. And that gets passed to a render function, which just uses the render I showed you earlier underneath to take virtual DOM trees from that channel and apply the changes to that element. So this has a few advantages over what I was doing before. In particular, it's simple, so it's easy to keep the whole thing in your head at one time. You know what the whole system is doing. It encourages a bottom-up data-driven design, just like Mark talked about on Monday afternoon. It's very good at undo-redo history because all of your application state is in one place. You can even implement a time-traveling system in it, like Elm has demonstrated. It works with Figwheel. It can work with dev cards with a little extra work. And it's amenable to property-based testing. So I've enjoyed working with it. I found that it's a lot easier to get up to speed with an application and get doing what you really want to be doing instead of having to monkey around with some larger architecture or library. And if you're interested in the code, it's on GitHub, creatively named VDOM. And that's all. Thank you.
As you said, my name is Nola Stowe. I'm from Austin. This is my first conj. I want to talk about cloud orchestration in Clojure. And you might wonder, what is that? And that's describing your cloud infrastructure in some kind of code so you can repeat it and things like that. So here's a sample from Azure, how they have their setup for their for their virtual machines and all of their things. And it's in JSON. And then Amazon, which you might have seen if you've used Amazon, is the Amazon CloudFormation, which is, I couldn't find a small example of this. So I just made it go the whole thing and run it over. So it's very long and very nested JSON. So I needed to do something like this for my project, and I wanted to do enclosure. And also, I didn't want to do the same thing for Amazon and then do the same thing for Azure. I mean, who wants to do the same thing differently, you know? And if Stu Calloway can be lazy, then he can be lazy too. But I'm told he's not really lazy, so. So there is a standard called TOSCA, which is a mouthful if you're trying to say it. So topology and orchestration specification for cloud applications. So TOSCA is much easier to say. So it's a standard, kind of like how you think, oh, HTML is standard, so here's TOSCA. It's currently in draft form, and it outputs into YAML, and here's what it looks like. And so I made a Clojure library for generating this. So this is the TOSCA YAML. A lot of nesting of everything, as seems typical. And so I didn't want to write all this all the time. So I wrote a library called CLJ TOSCA, which is the open source last week for my project. And we use the threading operator, so it's very easy to build up your all your properties for all your things. And we can export it to the format you like. So there's YAML, which is the standard, but we wanted to pass it to different apps, and so I made it also export to JSON, and because I like it. Eden, so here's Eden, and I was talking to Dave out there, and he said, well, why not transit? So I have some work to do this weekend. So the project is CLJ TOSCA on Clojars. Feedback and contributions is welcome. I'm Nola, Stowe, and I'm from Austin. My thing that got cut off. My blog is Clojure Geek, and same as my Twitter. I think that's it.
All right, thanks, Noah. And our next talk is about Clojars, and this is from Toby Crawley.
Good morning. Thank you. I've got about 70 slides, so I'm going to go really, really quickly. So I'm going to talk to you guys about Clojars. I'm Toby. So we're going to talk about where Clojars is now. Clojars is, for better or worse, has become a critical component in our ecosystem. And so currently, there's one administrator. That's me. I'm doing day-to-day, dealing with issues, system administration, deletion requests. It's on one box. We have backups of it, but it's one box, a Linode instance. Currently, Alex Osborne, who's the creator of Clojars, he still pays the bills. Even though he doesn't do Clojure anymore, he's not part of the community anymore, but he's still putting the bill for this thing. And it works most of the time, right? Not many complaints. But before we get to the next part of the talk, I want to say something like, this isn't doom and gloom, right? What I'm going to talk about is the state. It's been in the state it's in. It's been there for a couple of years, right? And it still works, right? But things need to improve. So let's talk about where Clojars needs to go, where I think it needs to go, and how we can get there. I think we need to make some changes to make it a robust, sustainable system. And I don't mean just the application itself. It needs to be more robust, but we need the organization around that, the people around that needs to be a sustainable thing. So how do we do that? And what does that mean? Well, there's the small potato stuff. There's administration, right? So it'd be nice if there was some people that were a backstop to me to do administration. A few weeks ago, I was at the zoo with my kids. We ran out of disk space, so Clojars was down for 5 hours, right? Because I couldn't do anything about it. And it'd be nice if we had some help, fixing bugs, dealing with issues. Then we have the watermelon-sized issues, and that's funding the infrastructure. That's ideally being able to pay for the infrastructure so Alex doesn't have to. And I would love to have enough money to contract out some larger pieces to make it more robust. And I don't have time to go into detail what those are, but I've got a lot of ideas of how we can make it a more robust system. And then there's the prize-winning pumpkin. And that is having some kind of legal entity around Clojars that can deal with corporate sponsorship and can make this thing sustainable. And by sustainable, I mean where we actually, people that work on it actually get paid, right? Because it's such a critical piece that if it goes down, I mean, it's worked so far, right? It's worked well, but as the community grows, that's more and more people that will be impacted if this thing goes away, right? So how can you help us get there? Well, for the small potato stuff, if you have time, you want to be an administrator, I'd love to talk to you about that. If you want to write code and work on Clojars, Nelson Morris, who was the previous administrator, he knows the system really, really well. And he's been doing a lot of work lately on modernizing the code base, using component, using SQL, eliminating a bunch of dead code. So now it's actually much easier to get into now than it was before. The watermelon stuff, you can now give me money. So I've set up where you can donate money. It goes into a bounty source account, and we can use that to pay hosting. We can use that if we have enough to do some contract work. It would be great if we could do corporate sponsorship stuff, but that doesn't happen yet. I don't think that's going to happen until we have a legal entity around Clojars of some sort. So the entity, the pumpkin in the room, I don't know how to do this. I don't have time to do this, right? So that's where I need help. I don't know if this needs to be a company taking over Clojars, a company formed around it. Ideally, I think it would be a nonprofit. I think since it's a community resource, it would be great if it was a nonprofit. I know Daniel Solano Gomez, are you in the room? So he's done a bunch of work on trying to get a Clojure Community Foundation started, a nonprofit. That would be a good fit for this, but I don't know where that is right now. And ideally, for this to be sustainable, I think that people that work on it should get paid to work on Clojars, and I think that it would be great if we had the resources to pay folks that have worked on it in the past. Nelson, Phil Hagelberg, Alex Osborne has put a ton of time. Alex has put a bunch of money into it. It would be great if they could get compensated for that somehow. This is what I want to do. But so if you have ideas about how to do this, I'd love for you to get involved. If you want to do this, that too. So if you want to get involved, there's the maintainers list. You can join that. That's where ostensibly discussions around Clojars will happen and do happen. And if you want to contribute, either with code or money, there's a contribute link now in the footer of clojars.org. You can click there. It'll take you to a wiki page which covers some of what I've covered today, and will also give you a link into being able to donate money. And that's it. Thank you very much.
So, greetings. My name is Ryan Haney. Online, I'm known as YoshiQuest. That's the GitHub right there. I'll go ahead and say that straight away because I have no issues and stuff like that. We really need help on that thing. But I'm just going to jump straight into this thing just because. So let's say that I'm assuming here that most of you know what Minecraft is or have at least heard of it. It is a game that's actually written in Java. So as such, there's a big modding community around it. And because of that, I decided, why not make it so that you can modify Minecraft in Clojure? So let's say that we want to add a block. Let's say def block, I can't spell today. Let's call it a conj block. And we'll give it a block name of that. Conj block. And let's just give it a texture name of, I think, like a conj mod colon conj block, and then it was, and then we need to specify a creative tab so that we can actually get to the block in game. So let's do creative tabs / block. And I think that's all you really need in order to create a simple block. So from there, we need to go and we need, if you just run this won't actually be able to do anything because we don't have a mod yet. So first of all, let's go ahead and create our mod's initialization functions so that we can actually create a mod. So let's say common init, and then we'll register. Oh, it takes an instance of the mod and the current event that it passes. This is on top of the Minecraft Forge API, which is what Minecraft uses. So then let's register conj block, and then give it an ID of conj block because I'm lazy. And then after that, we finally go into our core, and from here we just do def mod. This is probably my favorite macro that I've ever written. Def mod, and we'll give it the namespace, and conjmod.core. Give it your mod name, we'll just call it conjmod. Give it the version number, 0.0.1. And then now we just specify our common proxy, or in other words, will it be run on both the client and server. There's a client proxy thing, though I'll probably have to like write a post about it later or something. It's a bit more in depth than we have time for. So we'll make a common proxy of common slash of yoshiquest.conjmod.common slash common init, and I forgot that I need to put this in another map and specify that this is the init function, because there's inits, there's pre-inits, and there's post-inits. It's just different phases. It's just so I think that's pretty much it. So once you actually have your mod ready, you'll want to go into dev/conjmod. You'll want to go into the workspace for it, and you'll want to run /gradlew. Yes, it uses Minecraft Forge uses Gradle. I didn't have much of a choice in this. /gradlew run client. And now it'll take a little bit while Minecraft Forge, in combination with Clojars, if you ever heard of that library, which allows Clojure files to be compiled in Gradle. It'll be used with Clojars in combination in order to build the respective files, re-obfuscate the code, and a variety of other things. And assuming I didn't screw this up, it should work. It could take a little while because it's the first time I run it today. But ran it last night to test, but yeah. This is more, see there, okay, there it goes. Now it's compiling, and it crashed. Oh, gosh darn it, what did I do, Don? Oh. I did the wrong thing. It was, hold on, let me check my test mod. Oh man, see, I should have like made it back up or something. Blocks, it's block texture name, oops. So, okay, see, that'll do it. And now it shouldn't take as long to do it this time because it's already done it once. But yeah, this is more of a proof of concept, I suppose. It can actually do a lot more than just adding a simple block. I mean, there's like a dozen other things like custom rendering, MBT data, custom items, just, see, there it goes. See, now it's actually running, so that's great. There's just a lot of stuff that this can do. It's just that not a lot of people really know that it exists, I guess. So then let's go here, conj test. We'll open this up, and I'll just show you that, assuming I did things right. In building blocks, yep, we have a little conj block. You can place it. There you go. As you can see, I just successfully implemented Clojure in Minecraft. And you can just do whatever the heck you want from there, I guess. I mean, and this is just a simple proof of concept. I mean, like I said before, there's a lot more things that this can do, and there's a lot more things that I need to implement as well, like entities, GUIs, a lot of various other things, and a lot of bugs that I need to fix too. So, yeah. This was just a proof of concept and to show you that it exists. Again, the GitHub is yoshiquest/forge-clj. That is the API that this is built on top of. And I'll probably post the conj mod on GitHub as well if you really want that. So, yeah, that should be it. Thank you.